Matter phase modulation. In the workshop of matter, heat has always been our hammer. We melt, we forge, we temper, and in doing so, we scar the lattice, trading precision for permanence. But what if solid matter could be persuaded instead of burned? What if atoms could be coaxed into a pliable state and then guided back, unchanged, as if nothing happened? Matter phase modulation begins with a different belief, that solids are not static, but songs held in place. Every crystal hums with its own frequencies, phonons rippling through a lattice, electrons breathing around their nuclei. If you play the right notes, mechanical vibration and electromagnetic fields, precisely tuned and phase-locked, the structure relaxes. Bonds soften without breaking. The rigid becomes supple, not by heat, but by resonance. Imagine a bar of alloy at room temperature. No furnaces, no torches. Piezoelectric emitters whisper at the lattice's natural frequency while synchronized coils sweep high-frequency fields through the electron cloud. The phonons swell, the electrons shift, electrostatic grip loosens, and the crystal eases into a semi-amorphous, workable phase. Stop the music, and the lattice snaps home, its order restored, its strength unspent. The method is a choreography of 4 ideas. First, phonon softening. Drive the lattice at its own vibration and displacement multiplies, like pushing a swing at just the right moment. Second, electromagnetic polarization. High-frequency fields nudge electron density off-center, easing the pull between atoms. Third, metamaterial amplification. Phononic filters and split-ring resonators focus energy into narrow bands, so even dense crystals feel the right note with minimal power. Fourth, adaptive calibration. In shifting environments, near strong gravity, under warp fields, inside rotating habitats, the right note drifts. An AI synchronizer listens and retunes in real time, keeping the system locked to resonance as space-time itself flexes. In the lab, it looks like this: a shielded modulation chamber. The target fixed on a cradle. Sensors map its resonant profile, low-density metals answering in the hundreds of hertz, tougher alloys responding around a kilohertz, hard crystals waking only to megahertz or terahertz cues. The harmonic synchronizer aligns the drives. Piezo stacks start the mechanical pulse. Coils layer in the field. Femtosecond probes watch the lattice loosen without heat. Interferometers trace the shift in phase. Thermal control keeps temperatures steady far below melting. The sample yields, pliant, precise. Then the inputs fade and the crystal reorders as if rewound. The possibilities multiply. Paired with next-generation composites like Zetherium 7X, hull skins could flex with warp fields or wormhole boundaries, soaking up space-time shear and returning to perfect alignment on command. Quantum labs could tune lattices for entanglement, phase matching, or matter-energy interface experiments without ever cracking a crystal. Surgical microrobots could soften calcified tissue or reshape implants in situ, then let them resolidify seamlessly. On the Moon, Mars, or in orbit, structures could be formed, fitted, and repaired without welders. Materials softened, reshaped, and reset in vacuum with only a calibrated song. Limits remain, and the system respects them. Resonance is exacting. Frequencies drift under acceleration and gravity, demanding constant feedback. Dense materials ask for more energy or better focusing. Even non-thermal methods accrue stray heat, so cooling stands ready. No universal frequency exists. Each substance brings its own score, and the synchronizer must learn it. Yet the foundations are already under our feet. Ultra-fast pulses have shown lattices can be displaced without melting. Field-responsive materials strain and relax under electromagnetic cues. Metamaterials trap and guide waves with surgical precision. Interferometers hold phase in noisy, relativistic worlds. Matter phase. Modulation gathers these threads into one instrument and plays. Picture the closing sequence. A starship's panel shimmers as emitters hum. A warped seam relaxes, flows, realigns, and locks in place. In a clean room, a crystal wafer softens along a patterned field, channels sculpted without a single cut. In a clinic, a tiny device sings a calcification supple, performs its task, and lets the tissue set. No burn, no scar. The music stops. Order returns. This is not heat's dominion, it is resonances. Atoms, displaced and then redeemed. Solids, softened and then restored. A reversible passage between rigidity and flow that treats matter as a living medium, part of the same oscillatory universe that breathes in cycles of time and space. We are learning to speak its language, and when we do, we won't just shape materials, we'll shape the ways we meet the cosmos, gently, precisely, in tune.